If you are a hobbyist with a CNC mill, there is a good chance that you touch off your end mill or drill bit using a piece of paper. You may want to go paperless after I show you how easy it is to make and install a Z-Touch plate to your milling machine. In this video, I will show you step by step how I made and installed a simple Z-Touch plate using Mach 3. My Z-Touch plate is basically a piece of plastic drilled and tapped to secure a slab of aluminum with two brass screws. The dimensions for the touch plate are not critical. You can adapt my design to any length, width, and height to fit your needs. To allow for easy storage and for attaching the touch plate to steel, I created a small pocket in the plastic base to accept a magnet. Z-Touch plates can be purchased on eBay, but what is the fun in that? Give it a go and make your own Z-Touch plate. Here is the layout for my breakout board. In all the touch plate videos that I have watched, the host connects one wire from the Z-Touch plate directly to an input pin and a second wire to the input ground. It is probably overkill, but I made myself an optical isolator circuit for my touch plate. With the wiring taken care of, I configured Mach 3 under the Input Signals tab. I scrolled down until I found the word probe, clicked on Enabled, kept port number 1, entered pin number 15, clicked on Active Low, OK, and Reset. In the diagnostic screen, and with the touch plate touching any grounded surface of the milling machine, the green digitize light turns on. I found two great YouTube videos that explain the Z-Touch plate process, and both provided the necessary file to configure Mach 3 for free. Charlie Sarsfield emailed me his Z-Touch plate files and two audio files for sound effects in a compressed file. I decompressed it into a new folder. I also downloaded the text file 0 plate button script from the Guru Brew video, How to Set Up a Touch Plate, and saved it in a new folder. With Mach 3 running in the program mode, I clicked on Operator and then Button Edit Script. As you can see, Mach 3 buttons start flashing on and off. Clicked on the Auto Tool 0 button and a script editing program appeared. I deleted the information in this file using the backspace key. Using Microsoft File Explorer, I opened Charles' Z-Touch plate script, clicked on Edit, Select All, and Copy. Went back to the script editing program where I selected Edit and Paste. Charlie's Z-Touch plate information appeared. Selected File, Save, then Exit. I closed Charlie's file and restarted Mach 3. I needed to edit Charlie's Z-Touch plate script to enter the thickness of my plate. Again, with Mach 3 running in program mode, I clicked on Operator, then Button Edit Script. In the script editor, I changed 0.79 inches to 0.42 inches. I also changed the original 20.066 millimeters to 10.668 millimeters, saved, and exited. I was ready to try it. With the spindle off, I confirmed that the digitize light was on when I touched the touch plate to the end of the end mill, positioned the end mill less than an inch above my steel workpiece, left-clicked on Auto Tool 0, and a dialog box opened. I chose 0.42 and OK. After a few seconds, the end mill began to move. Keeping a finger on the escape key of the keyboard, I carefully watched as the end mill lowered slowly until it touched my aluminum plate and rose back up 50 thou above the aluminum surface. The Z-axis DRO indicated 0.470. So far, so good. I removed the touch plate from my workpiece. With the spindle on, using MDI and a slow feed rate, the end mill moved and stopped just slightly above my steel workpiece. I repeated the process by opening Engraver's zero plate button script, selected all of the text, clicked on Edit and Copy. Opened the button editor script editor in Mach 3. Using my mouse, I highlighted all the Charlie's text and pressed Delete. I repeated until all the text was deleted. I clicked on Edit and Paste, then Save. And then I exited the program. I then reopened the button script editor and changed the plate height from 0.6 to 0.42. I highlighted for you where to change the Z height from 1 to another value, saved my file, and exited. In the future, I will edit Engraver's file text before copying and pasting. His file does not allow for changing from inches to millimeters, but the program does check the touch plate to ensure that the touch plate is not grounded before moving the spindle. Before running his script, I confirmed that the digitize light was on when I touched the touch plate to the end mill, clicked on the Auto Tool 0, no dialog box appeared, but the dwell light flashed on and off. Seconds later, the end mill started to move slowly towards my touch plate. It stopped when it touched the aluminum and rose quickly up to 1 inch. I removed the touch plate and again with the spindle on, using MDI and a slow feed rate, moved the end mill to Z0. The end mill stopped very close to the top of my steel workpiece. I could hear the mill cutter brushing against the steel, but it left no markings on the steel. I was very impressed again. I hope you enjoyed this video. I am very pleased with both Charlie Sarfield and Engraver's work. I hope that now you too will decide to go paperless.